Welcome to this tutorial on splitting arrays with np.hsplit. In this video, you'll learn how to split NumPy arrays horizontally, which means dividing them along their columns. This is a powerful technique for working with multi-dimensional data in Python. np.hsplit is a NumPy function that splits an array into multiple subarrays horizontally, which means along the columns. When you use this function, it divides your original array into smaller arrays by separating columns, keeping the row structure intact. The basic syntax is straightforward. You call np.hsplit and pass two parameters. First, the array you want to split, and second, either the number of sections you want or a list of specific column indices where you want to split. Let's understand the two parameters. The first parameter is array, which is simply the input array you want to split. The second parameter is indices or sections, which can be either an integer specifying how many equal sections you want, or a list of column indices that define exactly where the splits should occur. Here's a practical example. We create a two-dimensional array with 2 rows and 6 columns, containing numbers from 1 to 12. Then we call np.hsplit with the array and the number 3. This tells NumPy to split the array into 3 equal parts horizontally. The result is 3 separate arrays. The first array contains columns 1 and 2 with values 1, 2, 7, and 8. The second array contains columns 3 and 4 with values 3, 4, 9, and 10. The third array contains columns 5 and 6 with values 5, 6, 11, and 12. Each resulting array maintains the original 2-row structure. You can also split at custom positions. Using the same array, we pass a list containing 2 and 4 as the second parameter. This creates splits at column index 2 and column index 4. The result will be 3 arrays, columns 0 to 2, columns 2 to 4, and columns 4 to 6. Let's recap the key points. np.hsplit splits arrays horizontally along columns. Use an integer to split into equal sections. Use a list to specify custom split points. The function returns a list of subarrays that you can access individually. This function is essential for data manipulation and preprocessing tasks in NumPy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.